In this question, assuming that in case of motion of blunt bodies in air, aerodynamic drag capital D, drag is a force only. Capital D depends upon effective area capital A of the body, the speed V of the body related to air and density of the air rho. Show by method dimensions, that is D is equal to K sigma A V square. So as usual, what we do is, first of all, we write D is what are the factors on which it depend upon. Drag is dependent on the factors A, V and rho. How it is dependent, we have taken as alpha, beta and gamma. You could have also taken as A, B and C. That is not a problem. You could have also taken as A, B and C. But generally over here, when you write A over here, that may create confusion to some of the students. So that's why I have taken alpha, beta and gamma, so that there is no confusion. So drag is what a force is mass into acceleration. I write the dimensional formula for D, A, V and rho at one place, and then simply I'll put the values, take the values and put it over here to make the job much easier, to make it much easier. So D is equal to m1 L1 t minus 2. V stands for velocity. Velocity is distance or displacement upon time. It is L1 t minus 1. Density is mass upon volume, mass upon length into breadth into height. Breadth and height, they have also a dimension of length only. So it is m1 L minus 3. Area is length to breadth. So obviously breadth is once again dimension of length only. So dimensional formula for area is L2. Now we pick these values, we pick the dimensional formula for these and put it in this equation. So D, dimensional formula for drag force m1 L1 t minus 2, area L2, raised to alpha, velocity L1 t minus 1, raised to beta, sigma m1 L minus 3, this is density over here, raised to gamma. You open the brackets, so L to the power 2 alpha, L beta, T minus 1 into beta minus beta, M gamma, L minus 3 gamma. We segregate the values into M, L and T. So first I write M is over here only, M gamma, L, can it from here to alpha, go towards right, to alpha, beta, and there is one more L, minus 3 gamma. T, I have only one T minus B, so minus T, minus beta. Because of principle of homogeneity, the dimensions over here and dimension over here, that should be same of M, L and T. So that's why we create the powers of dimensions of M and M on this side, L and L on this side, T and T on these sides. So 1 is equal to gamma, 1 equating the dimensions of L on this side and this side, 1 is equal to 2 alpha plus beta minus 3 gamma, and similar for T, minus 2 is equal to minus beta. So we get beta is equal to 2, gamma is already equal to 1. So we put gamma is equal to 1 and beta is equal to 2 in this equation. So we get 1 is equal to 2 alpha plus 2 minus 3 into 1. So we get alpha is equal to 1. We have got alpha also, beta also, gamma also. Alpha, beta, gamma values we have found out. Put the values over here. So D is proportional to the 8 to the power V. So D is proportional to 8 to the power 1, V to the power 2, and sigma raised to 1. So I have replaced this proportion sign by proportionality constant. So D comes out to be, D is equal to K V square and sigma. That is the answer.